So enzymes activity, or the rate at which they catalyze reactions, or efficiency of those reactions, can be influenced by certain factors. You may want to call them environmental factors or situational conditions. Okay, but the activity level of an enzyme can be influenced by some factors. Okay, and let's take a look at those. First, let's look at temperature. Okay, so we know that if we're talking about biological catalysts that are working within our bodies, whether that be to break down disaccharides into monosaccharides, break down protein structures into the amino acid primary structure, to do those, then the optimum temperature, the best temperature, would be right at body temperature. So the temperature of the reaction surroundings or reaction environment can influence the effectiveness of an enzyme. So, our body temperature is around 37 degrees Celsius is considered the optimum normal body temperature. So if our enzymes are working at that temperature range, then we're going to maximize the effectiveness, the activity level of the enzymes. If we get the temperature too high, if we get the temperature too low, then we get away from that optimum temperature, and we see a decrease in the effectiveness of the enzymes. Okay, it may be that it gets destroyed by the excess heat, like sterilized or killed. If it's too cold, then there's not enough kinetic energy, not enough movement, so the collisions aren't effective enough. They're not at that activation energy level. Okay, so enzymes do have an optimum temperature range. Okay, the pH of the reacting conditions or the reacting environment can influence the enzyme activity level. Okay, because if you think back to tertiary and quaternary structures of proteins, there you could denature proteins by causing changes in the pH of the environment, more acidic or more basic, by changing the pH level. So here, if we change the pH of the solution or the reacting environment, then the enzyme can change charges on some of the amino acid R groups within that enzyme. Because if you remember back, amino acids can be classified as polar neutral, polar acidic, polar basic in regards to those R groups. So if we change the pH of the reacting environment, reacting solution, we can start to change those forces establishing that tertiary structure, that quaternary structure, and the charges on those groups. Okay, on those groups. So we have to keep that pH. Now, if we think in terms of blood is around 7.4. Is kind of the physiological pH level. So, if we're, GI tract, maybe the pH is a little bit lower, around 6. Maybe in the liver, it's right at 7. Pancreas is a little bit basic at 8. Okay, so the enzymes are created and stored in different parts of the body, utilized in different parts, different organs, different systems. Those have varying pHs. So if the environment that the enzyme is reacting in, if that environment's pH changes, then we're going to change interactions, those force interactions. And then finally, the concentration of the enzyme or substrate. So think of this as how much is available. Okay, how much is available? Okay. So do we have a little bit or do we have a lot? Okay, so in any of these enzyme catalyzed reaction, the substrate needs to bind with the enzyme to form that ES, that enzyme substrate complex. So if you have a set substrate concentration and you increase the enzyme level, then the enzyme substrate complex can be made more. There can be more ES complexes, which would then increase the rate of the reaction. If you have a high enzyme concentration, then more molecules are available to bind with the substrate. And if that happens, then you get more catalyzed reaction to progress. Okay, so the key here is that as long as the substrate concentration is greater than the enzyme concentration, okay, so as long as substrate concentration is greater than enzyme concentration, then we'll see a direct relationship between enzyme concentration and enzyme activity levels. Okay, so we want to keep that substrate concentration high, is what we'd like to see if we're wanting to improve or increase the activity rate of the enzyme. Okay? So if we keep our enzyme concentration constant and we are able to add more substrate, then we get more reaction. Okay? Because if we have high substrate concentration, then we can get all the enzymes bonded together, you know, to make the ES complex. Okay? Now, we can reach a maximum rate here between the enzyme and the substrate. So we can get a maximum rate of reaction if we have substrate concentration greater than enzyme concentration and we continue to add more substrate. We aren't going to get more enzyme substrate complex. Okay, so we will just be sitting at a maximum rate, or like on cruise control. Okay, so if we increase substrate concentration, that does help get all the enzyme bonded together, but if we just continue to keep adding substrate concentration, we're not going to get more enzyme locked in, because if we've already got all of it locked in, we just have an excess of substrate. So if we increase both of these and we keep substrate higher concentration than enzyme, that's the most effective method for increasing the rate of the reaction.